This is a solution video for an expected value problem in Book 5, Exercise 7.2. It's page 206, question 17. So we're in a casino and there's two different games going on and it costs me €10 to play each. And one of the tables involves a deck of cards. So there's a couple of different things that can happen at the cards table. I can get hearts, in which case I win 30. Or I can get any other outcome, in which case I win 2. But now I do have to take into account that I paid 10 to play, so really the winning 2 is a bit of a sop to that. I need to take into account the tenner. So what am I really going to get in terms of these outcomes? So if I get hearts, then really what's happening is that I'm making a net gain of 20. And if I get anything else, I'm really having a net loss of 8. And I'm just getting those figures by taking my 10 that it cost me to play off both of my wins. Now I have to take into account the probability of winning. And of course, 1/4 of the pack is hearts and the other 3/4 is something else. And now I can work out my expected net outcome by using my formula for expected value, which I get by multiplying my outcome by the probability. And the outcome that I'm looking at here is how much money I'm actually getting to walk away with. So I've got 20 times 1/4 and 8 times 3, minus 8, because I'm losing it, times 3/4. I'm adding them up because of the instruction to sum from the formula. So what's happening overall is that I am going to have an expected return of -1. So what that means is I'm expecting to lose €1 on average every time I play. Okay, and then my alternative is that there's a table with 2 dice where you throw the 2 dice and you add the numbers that show, and then depending on your outcome, you win a certain amount of money. Now, it probably wouldn't be a bad idea at this stage to actually make out a two-way table for your 2 dice so that you can actually see what all the outcomes are. That way then you won't accidentally leave something out. So I've got my two-way table for my dice. And now let's have a look at what they're telling me. They're telling me that if I throw 2 dice and I get a total of 10 or 11 or 12, I get €50. And if I get anything else, I win 2. So I'm going to make out a table like I had for the cards over here for those outcomes in the dice. Okay, so with the dice, I've got my result of my 10, 11, 12, which they're telling me wins me 50. But of course I've paid a tenner already, so really I'm getting 40 back if that happens. And I can see from my table the probability of that happening. So I've got 1, 2, 3, 4, 5, 6 outcomes out of 36 equally likely outcomes. So it's 1 and 6. And any other total is going to win me 2. But I've paid my 10, so I'm really losing 8. And the probability of that must be 5/6. So now I'll use this table to work out my expected value of my outcome for the dice table. So again, it's expected value, and I want to multiply the outcome by the probability of the outcome. So that'll look like this. And this actually comes out as a net value of 0. So on average, I don't expect to win or lose playing this game. So just to make the point that when this happens, when it balances out between the person who's playing the game and the person who's running the game like this, so there's a net expectation of 0, this is what we call a fair game. So on average in this game, I expect to break even. So the question asks then, which game should I play to get the better expected return? Well, obviously it's going to be the one where I don't lose. I'm only breaking even. So the dice is the better choice in this case. And the difference then, which is the second thing they're asking us, the difference between the expected returns is that in one case I'm expecting to lose and in one case I'm expecting to break even. And notice how I'm saying on average. So I'm not saying that every time I'll break even with the dice. I'm not saying that every time I'll lose €1 with the cards. I'm saying this is what would happen if I played and played and played this game an infinite number of times and then averaged out all my wins and losses. You might wonder what the sense is from the point of view of the punter going through this calculation. Well, it lets the person who's playing know whether they're more likely to win or lose. But really, it's more a calculation that will be done on the part of the casino, because while they won't have an infinite number of people come through their doors playing the game, they will have quite a lot. And so this is a way for them to estimate whether they're going to make a profit or a loss. And of course, the loss for the punter is the profit for the casino.